Alright guys, welcome. This is Miss Scott and today we're going to start with our bad joke of the day before we get into some factoring. So, when is a door not a door? When it's a jar. Since it's not a door, it's a jar. Alright, so today what we're going to do is review how to factor some different types of polynomials. So you know how to do all these, but we're going to use factoring quite a bit in section 9.4. So to start here, we are going to review what the greatest common factor is. So when you're factoring, you always look for a GCF. Okay, that is always your first step. All right, so in these first two examples, we're going to see what these have in common. So I notice negative 15, negative 27, and negative 3 are all divisible by 3. And I notice the lowest power here is m to the power of 4. So that means I can take that out of each of these three terms and then see what's left over. So I'd have negative 5 minus 9m minus m to the power of 5. So all I did was subtract the powers by 4 and then divide each of those constant terms by 3. All right. It's always a good idea too to put your problem in standard form. So we would start with the negative m to the power of 5 minus 9m and put the minus 5 at the end. And this here would be our final answer. This is as factored as we can make this. All right, example 2, I notice that I have 4, 10, and 10 as my coefficients, which are all divisible by 2. I also notice that they all have a y in them. So I can take 2y out of each piece, and then that would leave me with 2yx plus 5y plus 5. So I am just reducing the power of the y's each by 1, and then I'm also leaving any x's in there because I didn't take any x's out. They weren't common to each term. So this here is completely factored. All right, our next two examples. The first one, we're going to look at factoring by grouping. And there is a typo here, so what I need you guys to do is erase or cross out this plus sign and go ahead and turn that into a minus. That was a typo. So when you do factoring by grouping, first thing we're going to do is group the first two terms and group the second two terms. Now when you group those second two, since there's a minus right here, when we distribute that back in, we want this to stay as a minus 18, which means we're going to have to turn that into a plus. Okay, so next step is now to take out the greatest common factor in each of those groups. So in the first group, I notice that 40 and 48 are both divisible by 8. I also notice that they have an n squared in common. So if I factor that out, I'm going to be left with 5n plus 6. So if I would redistribute that 8n squared, I would get back to the beginning. The second piece I have is minus 15 and 18 are both divisible by 3. And then if I factor out a 3, I have 5n plus 6 left over. Now notice what's left in parentheses is identical. So we're going to take these two pieces, pull those to the front. We've got 8n squared minus 3 in our first group. And our second group is going to be this 5n plus 6. All right, and that is actually complete. So you just did a factoring by grouping problem. All right, our next example is an easy trinomial, so our coefficient here is 1. So this we just have to make our factor diamond. We're trying to find two numbers that multiply to 20 and add up to negative 12. So if we think about that, I know negative 2 times negative 10 is 20. Negative 2 plus negative 10 is negative 12. So my answer is just x minus 2 times x minus 10. And that is all you need to do. Hence the name easy trinomial, just one step there. Well, let's look at if there's a number in front of that x squared term. So if our a is greater than 1. Then if you recall, we need to multiply the a and the c. So in this fifth example, we're going to get x squared minus 31x, and then 5 times 28 is 140. This is kind of a tough example because now what we have to do is find two numbers that multiply to negative 140 and add up to negative 31. Might take a little time on this one, but it does turn out that 4 times negative 35 is negative 140, and if you add those two numbers together, you get negative 31. So this is going to factor into x plus 4 times x minus 35. And then remember, we dropped this 5 at the beginning, so now we need to divide each of these constants by that leading coefficient. I can't divide 4 by 5, so that's going to pull up in front of this x. So our first factor is 5x plus 4. In the second piece, we have x, and then 35 divided by 5 we can do, that's 7. So this is our final factored form. Alright, let's try one more of those where the numbers are a little more manageable. So we're going to start here by multiplying a and c, giving us m squared plus 16m plus 3 times 20 is 60. Alright, so now let's think about this. What two numbers are going to multiply to 60 and add up to 16? So that one's not too bad. You can probably see that 10 and 6 are going to do that. So if we factor this, we'll get m plus 10 times m plus 6. And we got to bring that 3 back in. So we're going to divide each of these constants by 3. In our first factor, notice 10 is not divisible by 3, so we got to pull that up in front, giving us 3m plus 10. And the second piece, 6 is divisible by 3, so this is going to be m plus 2. Alright, so there's our factored form of that polynomial. Alright, to finish things up, last thing we're going to discuss in section 9.4 is difference of squares. So in general, a difference of squares is if you have some number squared minus another number squared. That always factors into a plus b times a minus b. So we just need to figure out what a and b need to be. Well, they're always just the square root of these two terms. So the square root of 16x squared is 4x. The square root of 9 is 3. So a and b are just 4x and 3. Okay, so this is our factored form of the difference of two squares. And then notice if you would FOIL this all out, 4x times 4x would give you 16x squared. 4x times negative 3 would be negative 12x, and this would be plus 12x, so those would cancel, and then at the end you would just have that negative 9. Alright, so it turns out that the two terms in the middle with the x's cancel out, and that is why you end up with just a difference of two squares. Alright, so if you guys have any questions on any of these examples, please let me know in class. Your homework is to work on the pre-9.4 worksheet.